Question 6, Part A. A wire of length 5 meters is to be bent to form the hypotenuse and base of a right-angled triangle PQR as shown in the diagram. Let the length of the base QR be x meters. Part 1. What is the length of the hypotenuse PQ in terms of x? The hypotenuse PQ plus the base QR is equal to 5 meters. Now, the length of QR is x meters, so we can form this equation. PQ plus x is equal to 5. Rearranging this equation to make PQ the subject, we get PQ is equal to 5 minus x meters. Part 2. Show that the area of the triangle PQR is half x times the square root of 25 minus 10x square meters. The area of a triangle is given by the formula half times the base times the perpendicular height. Now in triangle PQR, the base is QR and the perpendicular height is PR. Now the length of QR is x meters, but we need to find the height PR in terms of x. Now from part 1, we found the length of the hypotenuse, which is 5 minus x meters. And because we have a right-angled triangle, we can find PR in terms of x using Pythagoras' theorem. So PR squared is equal to PQ squared minus QR squared. So PR squared is equal to 5 minus x in brackets squared minus x squared. Now we have a perfect square here, which we can expand. So PR squared is equal to 25 minus 10x plus x squared minus x squared. Now the x squareds will cancel to 0. So we have PR squared is equal to 25 minus 10x. But we don't want PR squared, we want PR. So in order to obtain PR, we need to take the square root of 25 minus 10x. So PR is equal to the square root of 25 minus 10x meters. So the area of triangle PQR is equal to half times QR times PR, so that's half times base times perpendicular height, and that's equal to half times x times the square root of 25 minus 10x. So we get A is equal to half x times the square root of 25 minus 10x square meters, where A is equal to the area of triangle PQR as required. Part 3. What is the maximum possible area of the triangle? Part 3 is asking for the maximum possible area of triangle PQR. Now from part 2, we know that the area A is equal to half x times the square root of 25 minus 10x square meters. So we want to find a value of x which gives us the maximum possible value of A. Now this will involve the use of differential calculus. We'll need to differentiate A with respect to x, solve the equation A dash equals 0, find the value of x that gives us A dash equals 0, and then test to see if that value of x corresponds to the maximum possible value of A. Now in order to differentiate A with respect to x, we need to express A in terms of x using index notation rather than surd notation. So A is equal to half x times 25 minus 10x in brackets to the power of 1 over 2. Now we have a product of two functions of x, so to differentiate A with respect to x, we can use the product rule. So the first derivative A dash is equal to u dash v plus uv dash, where u is equal to half x, v is equal to 25 minus 10x in brackets to the power of 1 over 2. Now u dash is equal to half, and to find v dash we need to use the chain rule. And we get half times 25 minus 10x in brackets to the power of negative 1 over 2 times negative 10, which simplifies to negative 5 times open bracket 25 minus 10x close bracket to the power of negative 1 over 2. So putting that all together, using the product rule, we get A dash is equal to half times 25 minus 10x in brackets to the power of 1 over 2 minus 5x over 2 times open bracket 25 minus 10x close bracket to the power of negative 1 over 2. So writing A dash using surd notation, we get A dash is equal to the square root of 25 minus 10x over 2 minus 5x over 2 times the square root of 25 minus 10x. Now we can combine these two fractions together if we can find a common denominator. So if we take the first fraction and multiply the numerator and the denominator by the denominator of the second fraction, we can get two fractions with the same denominators, which means we can then combine the two fractions. So A dash is equal to 25 minus 10x over 2 times the square root of 25 minus 10x minus 5x over 2 times the square root of 25 minus 10x. Now that the two fractions have a common denominator, we can combine the numerators together to form a single fraction. So 25 minus 10x minus 5x, we have negative 10x minus 5x gives us negative 15x. So A dash is equal to 25 minus 15x over 2 times the square root of 25 minus 10x. Next we solve the equation A dash equals 0. Because we're dealing with a fraction, the only way a fraction can equal 0 is if the numerator equals 0. And in this case, the numerator is 25 minus 15x, and we're solving 25 minus 15x equals 0. Rearranging the equation, we get 15x is equal to 25. Dividing both sides of the equation by 15 to isolate x, we get x is equal to 5 over 3 meters. Next, we need to test if x equals 5 over 3 corresponds to the maximum area of triangle PQR. And we can use a table of gradients to check this. So here is my table of gradients. Now when x is equal to 5 over 3, the value of A dash is 0. And I've chosen two values on either side of x equals 5 over 3. So I've chosen x equals 1.5 to the left of x equals 5 over 3, and I've chosen x equals 2, which is a value to the right of x equals 5 over 3. Now when x is equal to 1.5, the value of A dash is 0.395, which is positive, so that's a positive gradient to the left of x equals 5 over 3. When x is equal to 5 over 3, of course we get A dash of 0, so that's a horizontal gradient. And when x is equal to 2, the value of A dash is negative 1.118 and so on, and that gives us a negative gradient to the right of x equals 5 over 3. So from the table of gradients, x equals 5 over 3 corresponds to the maximum area of triangle PQR. Now from part 2, we have area A is equal to half times x times the square root of 25 minus 10x square meters. So when x is equal to 5 over 3, substituting this value for x here and here, we get A is equal to 2.4056 and so on. I haven't written the full decimal on the calculator screen, so I'm going to round the answer correct to 2 decimal places. Therefore, the maximum possible area is 2.41 square meters, correct to 2 decimal places, or 25 root 3 over 18 square meters in exact form.